Words are fascinating things. They're not static objects frozen in time. Instead, they're living entities, always evolving and transforming with the cultures that use them. Words travel across continents and centuries, their meanings shifting, expanding, and sometimes twisting into something entirely new. We often use words without a second thought for their origins, with their secret history hidden just beneath the surface. The word algorithm is a perfect example of this linguistic journey. Nowadays, it's a cornerstone of our digital world, a term that's pretty much synonymous with computers, artificial intelligence, and the complex systems that, well, govern our lives. But its story doesn't begin in a modern laboratory or a Silicon Valley startup. It actually begins over 1,000 years ago, not with a concept, but with a man. To truly understand what an algorithm is, we have to travel back in time. We need to journey to the golden age of Islamic science, to a vibrant city that was the intellectual heart of the world. Our destination is 9th century Baghdad, a place of immense learning and discovery. It's here that we uncover the surprising origin of a word that now defines our modern era. The story starts not with code, but with a name: Muhammad ibn Musa al-Khwarizmi. The word algorithm is a bridge across time, and by walking across it, we can gain a deeper appreciation for the intricate and often surprising ways in which our world has been built. One brilliant idea, and one powerful word, at a time. Our story begins in Baghdad around the year 820 AD. This was not just any city, it was the thriving capital of the Abbasid Caliphate and the epicenter of a remarkable intellectual movement. At its heart was the Beit al-Hikmah, or the House of Wisdom. This was more than a library, it was a grand academy, a translation center, and a scientific observatory. Scholars from across the known world gathered here, drawn by a shared passion for knowledge. They translated Greek, Indian, and Persian texts into Arabic, preserving and building upon the wisdom of ancient civilizations. It was in this extraordinary environment that our protagonist, Muhammad ibn Musa al-Khwarizmi, made his mark on history. Al-Khwarizmi was a brilliant Persian scholar, a polymath who excelled in mathematics, astronomy, and geography. This was the Hindu-Arabic numeral system. The Indian system, with its place value notation and the magical zero, made calculation dramatically simpler. He decided to write a book, a practical guide to explain this new method of calculation to the Arabic-speaking world. This mission was profoundly important. Al-Khwarizmi's most influential work on this topic was a book written around 825 AD. Its full title was Kitab al-Jam wa al-Tafriq bi Hisab al-Hind, which translates to The Book of Addition and Subtraction, according to the Hindu calculation. Addition, subtraction, according to the Hindu calculation, the Indian numerals and place value system. In this groundbreaking text, he laid out the rules for performing arithmetic using the Indian numerals. He explained step by step how to carry out calculations that were previously cumbersome and difficult. This book was a user's manual for a new and superior mathematical technology. It was so practical and so clearly written that it became essential for scholars and merchants. But Al-Khwarizmi's genius did not stop there. He wrote another, perhaps even more famous book, Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, the compendious book on calculation by completion and balancing. From the title, specifically the word al-Jabr, the Western world derived the word algebra. In this work he presented a systematic way to solve linear and quadratic equations. The term al-Jabr referred to the process of moving a negative term from one side of an equation to the other and changing its sign. Al-Muqabala, balancing, meant simplifying both sides until like terms remained. He wasn't just solving isolated problems, he was creating a general method, a repeatable recipe for whole classes of problems. This was a true algorithm, a finite sequence of well-defined, computer-implementable instructions. He was providing a foolproof recipe that, if followed, would always lead to the right answer. His work transformed mathematics from a collection of puzzles into a systematic science. While he never used the word algorithm himself, his approach embodied the concept. His methods paved the way for his name to become the future label. For several centuries, Al-Khwarizmi's works remained pillars of science in the Arabic-speaking world. Europe, meanwhile, was still deep in the Middle Ages, largely reliant on the cumbersome Roman numeral system and the abacus for calculations. The winds of change began to blow in the 12th century. Scholars in Spain, scholars in Italy started translating the great works of Arabic science into Latin. Among the most eagerly translated texts was Al-Khwarizmi's book on Hindu-Arabic arithmetic. It was this process of translation that began the curious transformation of a name into a concept. When European scholars translated his book, they needed a way to refer to the author and his new method. They Latinized his name Al-Khwarizmi into algorithmus. At first, this new word, algorithmus, simply meant the new system of arithmetic using Indian numerals, as opposed to the old abbacism. A book teaching this new method might be titled Liber Algorithmi, or the Book of Al-Khwarizmi. So, if you were a scholar in the 13th century who practiced algorithmus, it meant you were using the modern, efficient decimal system for your calculations. The name of the man had become the name of his method. Over the next few hundred years, the word algorithmus continued to evolve. Its spelling shifted to algorithm, the form we use today. The journey was complete. A Persian mathematician's name, Latinized and misunderstood, had evolved over a millennium to become the perfect term for the digital age. Although the word algorithm only gained its modern, precise meaning with the advent of computers, the concept itself is actually ancient. An algorithm is simply a step-by-step recipe for achieving a goal. Humans have been creating such recipes for millennia. Euclid, the ancient Greek mathematician, lived around 300 BC, more than 1,000 years before Al-Khwarizmi. He devised a method for finding the greatest common divisor of two integers. The procedure, called the Euclidean algorithm, perfectly illustrates the idea. Simple, elegant, foolproof. It always yields the correct answer for any two numbers you start with. Consider the sieve of Eratosthenes, an algorithm to find all primes up to a given number. First, list all the numbers. Cross out multiples of 2, cross out multiples of 3, cross out multiples of 5, and so on. The numbers left are primes. No genius required, just follow the rules. We see algorithms in ancient crafts and arts, weaving a complex pattern on a loom, the sequence of steps for building an arch, a recipe for mixing a specific paint color. Each is a sequence of operations that produces a predictable, repeatable result. The key: reduce a complex task into simple, executable steps. The human brain has always tried to systematize tasks and create order from chaos. That impulse is the root of all algorithms, executed by hand, machine, or computer. What was missing was a machine to execute these recipes with superhuman speed and accuracy. The story of the algorithm takes a dramatic turn in the 19th century in Victorian England. Here we meet Charles Babbage, a brilliant and often cantankerous mathematician and inventor. Babbage was frustrated by errors in hand-calculated mathematical tables, navigation science engineering. Humans, he realized, were unreliable computers. He dreamed of a machine to perform calculations automatically and flawlessly. His first design was the difference engine, a massive mechanical calculator to tabulate polynomial functions. A machine built to execute one specific complex algorithm. Babbage's ambitions went far beyond a single-purpose calculator. He envisioned the analytical engine, a far more powerful general-purpose machine. Unlike the difference engine, the analytical engine wasn't limited to one task. It could be programmed to execute any algorithm. It had all the essential components of a modern computer: a mill for calculations, which we would now call the CPU, a store for holding numbers, memory, a reader for inputting instructions, punched cards, a printer for output. A general-purpose computer conceived a century before the technology existed to build it. But hardware is useless without software. Enter Ada Lovelace, daughter of Lord Byron, a gifted mathematician fascinated by Babbage's work. She wrote a detailed method for calculating Bernoulli numbers. Those instructions are now considered the world's first computer program. She was first to grasp the concept of software, the world's first computer programmer, the first true algorithmist of the machine age. For nearly a century, the ideas of Babbage and Lovelace remained a historical curiosity. The mechanical technology of the 19th century was simply not up to the task of building a machine as complex as the analytical engine. The algorithm was a powerful concept, but it was still waiting for a vessel fast and reliable enough to unleash its true potential. That vessel arrived in the mid-20th century with the invention of the electronic digital computer. The gears and levers of Babbage's mechanical dreams were replaced by the silent, lightning-fast switching of vacuum tubes, transistors, integrated circuits. This was the dawn of the digital age, and it was the moment the algorithm finally found its true home. Early electronic computers like ENIAC and Colossus were designed for specific, urgent tasks, calculating artillery firing tables and breaking enemy codes during World War II. The programmers had to physically rewire the machine to change the algorithm it executed. But the pioneers of computing, such as Alan Turing and John von Neumann, were building on the theoretical foundations of logic and computation. Turing, in his 1936 paper, had conceived of a theoretical universal machine that could simulate any algorithm. Von Neumann's architecture then provided the practical blueprint for a stored program computer, where the instructions, the algorithm, could be held in memory right alongside the data. This was the critical breakthrough. Suddenly computers were no longer single-purpose machines, they became universal algorithm executors. Changing a computer's function no longer required rewiring, it simply required loading a new program, a new algorithm, into its memory. Computer scientists began to develop and refine a vast library of algorithms for all sorts of tasks. The age of the algorithm had truly begun. Today, we live in a world built by algorithms. They are the invisible architects of our digital lives, working silently in the background of nearly every interaction we have with technology. Most of the time, we don't even notice they are there, but their influence is profound and pervasive. From the moment you wake up to the moment you go to sleep, you are interacting with dozens, if not hundreds, of different algorithms. The alarm on your smartphone that wakes you up might use an algorithm to adjust its timing based on your sleep patterns. When you pick up your phone and scroll through a social media feed, a complex curation algorithm is deciding what you see. When you open a navigation app to check the traffic, a pathfinding algorithm is calculating the fastest route to your destination in real time, analyzing data from thousands of other users to predict congestion and offer alternatives. The world of commerce is entirely dependent on algorithms. When you shop online, recommendation algorithms suggest products you might like based on your browsing history and the purchases of similar customers. Streaming services like Netflix and Spotify use sophisticated recommendation algorithms to suggest movies and music, creating a personalized experience designed to keep you watching and listening. Search engines like Google use the legendary PageRank algorithm and its many successors to sort through trillions of web pages and give you the most relevant results in an instant. The autocorrect on your phone, the spam filter in your email, the voice assistant that answers your questions. All of these are powered by intricate algorithms that have been refined over decades of research and development. The journey of the word algorithm is a mirror of our technological and intellectual progress. It began with the name of a single man, Muhammad ibn Musa al-Khwarizmi, a scholar in 9th century Baghdad who gave us a systematic way to solve problems. The simple, step-by-step procedures that al-Khwarizmi wrote out with a quill pen are now executed billions of times per second on the silicon chips inside our smartphones. The journey of his name is a testament to the idea that a single person's contribution, passed down through the ages, can truly change the world.